Friends, in day-to-day life activities, we come across various forces, like force while interaction with each other, like handshake, force while you strike a hammer onto a nail, force the gravity is applying on you. So all these forces were finally classified under 4 major categories, and they form the 4 fundamental forces for us. What are they? Let's see. The very first one is the gravitational force, which you are very well aware of. Then comes the electromagnetic force. We are going to explain that to you. You already know it a little bit from class 10th experience. Then moving on, we are going to understand strong nuclear force. This is a new force for you. And then we move on to weak nuclear force. Again, this is a new segment. So let's start with the one which you know very well, that is the gravitational force. Now, the gravitational force, as you can see in the diagram, you can find that there are 2 masses m1 and m2, and the distance between these two is r. Both the masses, by the virtue of nature, they are attracting each other by the value of force F, and that force can be given by this formula, that F is equals to G m1 m2 upon r square, where G is what? The gravitational constant. And what is the value of gravitational constant? Yes, it is 6.67 into 10 to the power minus 11 Newton meters square per kg square. So any 2 masses in the universe, let's suppose there's a suite in a hotel and the tongue in your mouth, they attract each other, and that force is only due to the mass, and that is known as gravitational force. Now don't laugh, we need to understand the properties of gravitational forces as well. Let's see important properties of gravitational force. Now you can see here that gravitational force is the weakest force in universe. Yes friends, you have to be aware that it is the weakest among all the fundamental forces available. But you read a term weak nuclear force. Friends, the term weak does not mean that it is the weakest. Gravitational force is the weakest force among them. Now when you talk about the second thing, these are the universal attractive forces. Yes, it's by nature. Gravitational force is always attractive. It's never repulsive in nature. This is the important one, friends. Then the third is they are central forces. Now what do you mean by the central force? As you can see here, when the 2 bodies attract or repel each other and the forces act only along the line joining their centers, those forces are known as central forces. And we have some unique properties for these central forces. Let's see what are they. They obey inverse square law. That means the force is inversely proportional to r square. What was r? The distance between the 2 bodies, right? Now, if you move ahead, you will find that they are conservative in nature. All the forces which are central in nature are conservative. Now, what do you mean by conservative forces? The work done by these conservative forces in a cyclic path is 0. Suppose you throw a ball up and then it comes down. The work done by gravity across the closed loop would be 0. So that is, they are conservative forces. Then they are mediated by the particles called graviton. Now in a theory, it is said that these 2 particles interact with each other with the help of a mediating particle. Suppose you are sitting at a place and you want to transfer your force to a friend. You go and slap that person directly. That's a direct contact and the force has been transferred. But suppose you have a fear that if I go near him, he may hit me again. So what you do, you take a piece of chalk, sit at a distance and throw that chalk to that person. This will happen that the force will be transferred to on that person, that is via help of that chalk, which helps or which acts as a mediating particle. So that's why the force of gravitation acts by the help of the graviton particles, which is the mediating particle. Moving ahead, they are not affected by presence of other bodies and intervening medium. Right? So these are the points you must remember about the gravitational forces. I hope you have understood these. Now let's move on to electromagnetic force. When you talk about the electromagnetic force, it is very much similar to gravitational force, but now in this case, this is charges which are being affected. So here there are 2 charges which are separated by distance r, and they are attracting or repelling each other with a force of F equals to 1 upon 4 pi epsilon naught, Q1 Q2 upon r square, where Q1 and Q2 are the charges of these bodies and r is the distance between these 2 point charges. And as you can see, r is the distance of the line which is joining the two centers of these two bodies. Yes friends, you are right. Electromagnetic force is also a central force. Let me show you. So if you see the important properties of electromagnetic forces, the very first is they are governed by Coulomb's law. Yes, the force formula you see that F is equals to K 1 upon 4 pi epsilon naught Q1 Q2 by r square. It's a Coulomb's law, friend. Then they may be attractive or repulsive. Pretty obvious. If they are like charges, they will repel each other. If they are unlike charges, they will attract each other. Then they are central forces, as I have already told you, and since they are central, they will follow the inverse square law, as you can see in the formula itself, where F is inversely proportional to r square. Moving ahead, they are conservative in nature as per the central force law, and then they are mediated by the particles. They are known as photon. Yes friends, photons are the same particle of which the light is constituted. So photon are the mediating particles for electromagnetic forces. Then these forces are effective till infinity. That means the gravitational force and electromagnetic force, since the force is inversely proportional to r square, force will be zero when the distance would be infinite. I hope you have understood the two forces, and there's quite a similarity between these two, right? Apart from the difference that gravitational force is always attractive, whereas electromagnetic force can be attractive and repulsive. And second thing, the gravitational force, it is not affected by the intervening medium, but the electromagnetic force, it is affected by the intervening medium. The detail of electromagnetic forces you will be studying in class 12. Now it's time to take on to our next two forces, that is the strong nuclear force and weak nuclear force. Now you see strong nuclear force. Before we proceed ahead, let's understand where these forces are acting. You know what an atom is, right? And within that atom is a small sphere, that is nucleus. It's a very confined space having a very small radius of nearly 10 to the power minus 14 or 10 to the power minus 15 meters. So the forces of strong nuclear force act within the boundary of nucleus only. They do not act beyond it. And it is one reason why the nucleus is stable. Yes friends, in the absence of strong nuclear force, you will not be able to justify that how those many protons are residing inside the nucleus within that confined space, in spite they all are of like charges. So let's see what strong nuclear force is. It is the force which binds nucleons, that is protons and neutrons in the nucleus. Then it should be a strong attractive force that counteracts the repulsive force of protons and keeps nucleus stable, right? Then it is the strongest of all fundamental forces. Obviously, it should overcome the electromagnetic force which is acting between the protons. Then only it can keep the two protons together. Now moving ahead, if you see the properties, that they are charge independent. Friends, it is very important because they act on protons and neutrons as well, which are neutral in nature. That means the strong nuclear force is charge independent. Second is they are the strongest force, that means 100 times stronger than the electrostatic force. Remember it. So that's why it's the strongest one. And gravitation was the weakest one. Always remember. Then they have the short range. As I said, it extends only up to a range of 10 to the power minus 15 meters, and they are basically attractive forces only. They are not repulsive because they have to keep things together. So this is also important. Now you can see weak nuclear forces. Obviously, they are also acting within the boundaries, but friends, they are the forces between the elementary particles of short lifetimes. And what are the important properties? If you see, it exists between the leptons and leptons in mesons, which are the small elementary particles which are very short-lived, right? Then they are mediated by the particle which is known as bosons, and they have the shortest range of 10 to the power minus 16 meter. So what is the largest range possible for the forces is the infinite range for the gravitation and the electromagnetic forces, and the shortest would be the 10 to the power minus 16 meter for the weak nuclear forces. In and all, while I was teaching you all those things, I wanted to compare these forces along so that it's important for you to remember, and that is one segment where one question will definitely fall. So as you can see, we have a table where we'll be presenting all the forces together and what are the important parameters we have to figure. That is the name of the force, what is the relative strength. That means we will focusing that what is the strongest force, we will keep it as 1, and the rest of the forces we will be comparing it with respect to the strongest force. Then the range of the force and the mediating particle. And I am sure that one question will be from this segment. Let's start with the very first force, that is the strongest force, which is of course strong nuclear force. As the name suggests, it is, since it's the strongest, I have kept it as a base, that's why the relative strength is 1. What is the range of this force? That is 10 to the power minus 15 meters. And what is the mediating particle, friend? It's pi meson. Now let's move on to our next strongest force, that is the electromagnetic force, which is 10 to the power minus 2. Remember, I have told you that strong nuclear force is 100 times stronger than the electromagnetic force. That means electromagnetic force is 1 upon 100 as compared to the strong nuclear force. That's why it is 10 to the power minus 2. What is the range of electromagnetic force? Since it's a central force, the F is proportional to inverse of R square. So infinite is the range. And what is the mediating particle? That is the photon. Moving ahead, if you see, we have weak nuclear force, which is 10 to the power minus 13 as compared to the strong nuclear force. And the range would be very short, that is 10 to the power minus 16 meter, with the mediating particle as boson. And moving on, the weakest force, that is the gravitational force, with a relative strength of 10 to the power minus 39 with range infinite and mediating particle of graviton. So friends, one common question which has been asked, and you may find in your study package as well, that what is the relative strength of electromagnetic force and the gravitational force? It will fall up to be 10 to the power minus 37 or order of 10 to the power minus 38 as well. You may find these options. And remember, relative strength may vary for a typical kind of interaction. It's a general formula I have given to you. I hope you have understood what are the fundamental forces and how they are interrelated to each other. Now in the next video, we will talk about the unification of forces, and then we will move on to laws of nature. I hope this was helpful. Now